Okay, we're going to do a reverse engineering process with some scan data. I'm going to import the scan data, make sure it's the right size. Now it is. Imported scan data looks like this. If we're dealing with different scan passes, we might want to run the mesh buildup wizard. A lot of scanners these days export a mesh that's all complete, like so. So in this case, all we're going to do is decimate the scan data down, reducing the size of the mesh, the density of the mesh, but not really changing the shape very much, negligibly. Okay, so we're not changing the shape. Now we're going to consider doing a NURB surface. We're not going to do NURB surface, but if we were, we could do a hole filling, or we could defeature areas that we didn't need. We could smooth some areas of the mesh out, head to the boundaries, even optimize the mesh so that we could run something like an auto surface to get a NURBS representation, but that's not really applicable here. So we're going to skip to aligning this scan data set to the origin. What you'll notice is that this is kind of off at a diagonal. It's not really square to the origin. We have some tools like the plane tool, where we can fit a plane to different points on the mesh, and once these points are selected, they get fit to the mesh, and we can use that to align to the origin. What's an easier method is to run the auto segment tool, and what this does is it breaks the scan data up into these regions of mesh, and it should only take a second, but with the video turned on, who knows. And what we'll have after this is created, let's just pause the video. Okay, we restarted the video. Yeah, we're rolling. So usually that only takes a couple of seconds, but with the video, who knows, it seemed to take an awful long time, almost 30 seconds to calculate, which is a little long. Anyways, this auto segment process now allows us to automatically have these regions selected. So this is identified as a plane, this is identified as a cone, and this is identified as a sphere. And actually, one of the easier ways to show this is by changing the visualization so that blues are planes, yellows are spheres, and oranges are revolved shapes. So now we've got the data in this with these segments, and I can run the align wizard, which will automatically analyze all of the geometry, suggest a couple of candidate coordinates, and just like that, we've got the scan data aligned to a coordinate system. So now we can start doing some modeling using the modeling tools and modeling wizards. We've got the mesh sketch tool and all the associated functions from that, like an extrude or a revolve. And this is kind of the manual way to create a feature, so let's just show that real quick so we can compare and contrast to the wizards. The mesh sketch setup allows you to choose a plane to sketch off of. You take any section that you want of the mesh. Say I want to get the base shape, which is that right down there. And what we can see is that we've got this polyline. It's called a polyline, and we can actually fit geometry to the polyline. So we can fit lines and arcs to the polyline, and what happens is constraints are added, like horizontal constraints. We can add fillets if we wanted to. We can add a sketch fillet. We can dimension this sketch up if we needed to. And once we have this sketch, we can run something like the extrusion, and we can extrude this sketch. Just show the mesh for a second here, up and down, high enough and low enough through the model, so that we've got a solid that's created. Okay, so this is a solid that's created, and what we can do now is it seems impressive, but what we can do now is we can check the deviation and see how close that is to the scan data. And what we're presented with is a color map. So based on some nominal values of deviation, say plus or minus 4 thousandths of an inch right now, we can make this looser, maybe a little more realistic, plus or minus 10 thousandths of an inch. That this wall doesn't quite match up to the scan data. It looks like this wall's drafted, and we've extruded that wall straight. So this manual process was pretty fast, but it didn't quite capture the draft in the wall. So what we're going to do is we're just going to hit undo once and undo again, and show a different way of creating an extrusion, and it's going to be an extrusion wizard. So the extrusion wizard allows you to pick some of the sides of the mesh, and this is a really powerful tool because it will automatically estimate the extrusion direction. Okay, so you can estimate the extrusion direction and tie that to a specific plane, like the right plane. Automatically estimate the draft angle, and you'll see what takes place is a solid gets created. We can pull that solid up enough, and that's That's what the extrusion wizard does. So more of an automatic command, generating the same sketch and extrusion in the model tree. If we look at the deviation, hit the deviation button, we can see that this model is accurate and it captures all of the draft from the scan data. Okay, so that was pretty easy to do. Next thing we're going to do is use that same command again, the extrusion wizard, and cut the pocket out. Okay, so we'll choose the sides, we'll choose the bottom. We can estimate the sketch plane, and in this case, instead of a solid merge, we'll do a solid cut. And that cut does exactly what you'd expect it to do. You've got the solid model created. You can check the deviation between the scan and the CAD, and we can see it is pretty accurate. In this point in time, I'm gonna look at the fillet geometry and run a fillet estimator right across here, because we don't quite have that fillet geometry nailed. So the tool, the fillet tool, allows me to estimate the radius from the mesh. This is a radius estimate, and after I run that command and check the deviation again, you can see that I'm now capturing all the error. There's no error in this model at this point. I'm at least in that area of the geometry. Okay, so let's show the mesh and hide the solid again, and now we'll tackle this top freeform cut. And the way to do that is we've got this great tool called the mesh fit surface that'll create a surface as accurate as you ask it to. If I want the allowable deviation to be plus or minus 10,000th of an inch, I can ask it to be that deviation. If I want it tighter, then I can ask it to be tighter. And what is created is this really really accurate surface from the mesh fit surface command, and I can use that to do a cut. So I can use this as a cut tool to cut away from the solid, keep the solid geometry, and at this point I don't need the surface anymore, so I can just delete that surface. Again, we can take a look at the deviation between the scan and the CAD and see that this top surface fits really well. We might want to run a fillet command off of this edge and do the same fillet estimation to estimate a fillet radius. This is telling me a 0.038. Might square that up to 0.040. I square it up to 0.040 and run that command. And now if I check the deviation again, no surprise, I'm tighter in that area of the mesh. I might as well finish out some of the other fillets here. I can run it off of this side, estimate the value. Value is estimated at 0.048, so I'm going to make this a bigger radius now, 0.05, and see what is left to do. Okay, so the next thing I'm going to tackle is the revolved shapes. For the revolved shapes, I'm going to hide the solids, show the mesh again, the revolution wizard, and now I'm going to pick the revolved shapes of the model. So I'm going to do a solid merge between these pieces of geometry. That's the estimated geometry. You're going to take a look at smart visibility. You can see what that looks like, exactly what I expect. Okay, I can run that again on this area of the mesh. And one last time on this area of the mesh to get all of the revolved geometry created. Now if I show my solids, hide my mesh, I can see that I've got this solid geometry created here. Now one thing that this command did was it didn't quite create the sketches long enough, and I'll show you what I mean in a second here. If I look at the sketch, the bottom of the sketch isn't quite long enough, so it doesn't extend far enough to touch the base solid. So I can modify that sketch, and that will now touch the base solid. If I modify this sketch and drag it down, that's going to be guaranteed to touch the base solid. If I modify this sketch and drag it down, that'll guarantee to touch the base solid. And I can perform other operations like dimensional, smart dimensioning of the model if I needed to at any point when I'm editing this sketch. Alright, so now I've got one solid body, the revolve, and let's take a look again and see how close we are to finishing this model. Okay, we look pretty close. It looks like there's some kind of plastic warpage right there. This is the embossing on the plastic model. We're not going to worry about that. There's clearly a couple of areas of the model that we need to model in. So let's tackle this one here first. Okay, if I show the mesh and run the extrusion wizard again, I can choose the sides, 2, 3. I can choose the bottom, and I can make sure I run the solid cut. to cut that body away. Let's take a look. Okay, that looks pretty good. We'll do it over here too. Here's the extrusion wizard. We're going to choose the sides. 1, 2, 3. We'll choose the bottom, and we will press the solid. We'll make sure this is a solid cut, and run that command. Let's take a look at the solid that's created. That looks okay, but actually the sketch didn't quite form the way we wanted to. And one of the very nice things about Design X is that I can modify the sketch just by simply going into the sketch, checking it out, and modifying it. So what I'm going to do here is I'm going to delete some of these edges. I'll hit the delete key and add some new lines, rather, like so. And then close those lines with the coincident constraint, which automatically joins some of the lines. So by doing that, no surprise, the solid body's now updated. This is a parametric modeler, and we have that that geometry exactly where we need it to be. At this point, I can run some fillet commands on this edge and this edge, and then we'll hit the estimate button. It'll look at both of those edges. I think they're about the same radius, and it'll apply that radius across both edges. Heck, it might be this edge too. Why not? Let's just do that. And we have that created. Check the deviation of the model. I think that was a pretty good guess. We have those fillets created. Now the last set of features here seem to be in this area, and we'll take care of these last hole cuts at the very end as well. Okay, so let's create a slot cutout. But in this case, instead of using the wizard command, I'm going to go back to my trusty old manual process with the mesh sketch setup. I can use the base plane by simply clicking on the region. So the region has a plane associated with it, so I can select that base plane and make sure that I get in my mesh sketch setup a cross section that captures the slot geometry. And I sure have there. So now if I look at this geometry and get it zoomed in and narrowed in, I can use my tools like the auto sketch to get those lines and arcs, or in this case the slot tool makes a lot of sense. So I can just pick the geometry and fit the slot and apply any constraints that I might feel applicable, like a smart dimension across the geometry to get this lined up to exactly where where I want it to be. So that's a fully constrained sketch there. With that geometry modeled, I can use the extrusion tool to extrude that up and cut away from the model. And at this point, we'll see this geometry nearly completed. And the fillets, once again, to this edge. You can estimate the radius of the fillet based on the scan data, that's a smaller value. If I wanted to square this up to 0.020, I could do that now. And do one last check and see what we're missing. Yeah, so we're missing 3 more cuts out through the model. And again, the way that we're going to tackle these is with mesh sketch. And the way that we're going to do this mesh sketch, instead of trying to get a sliver of the scan data that goes through each of those sections, I'm going to use this tool called the silhouette tool, which basically shines the light up and down through the model. By shining a light up and down through the model, what I have is this view of the geometry, and I can fit a circle to this area of the model. I can fit a circle. Now it doesn't really look like I've got great scan data down here. I think this is missing scan data, so I'm going to just fit a circle to the best area of the model, which I think is right there. Yeah, I think that's the best area of the model. And we'll fit one more slot geometry right here. And of course, we could offset the slot if we wanted to. There's all sorts of ways to fit a slot, but we'll just use a sketch fit slot like so. And then with those sketch geometries, we can extrude up and down. We can go through all, just do a mid-plane extrusion that cuts through the entire model. And what we have at this point is basically a completed model. The model is really quite accurate to the scan data. We've got the holes modeled in. We've got a lot of fillets and secondary features modeled in. We've taken care of all the draft. The bottom's not quite accurate. So if we wanted to do something like run a shell command on the entire body. We could do that, where we remove some of the faces. And running this command really shows that you're dealing with a true solid geometry here. So you're able to run a shell command and get this ready to go inside of your CAD system. Okay, so we're about done now. Probably the last step for exporting or live transferring the model is to do a capture screen, and this capture screen is really helpful for saving the accuracy of the overall model. If there's some part that wasn't modeled, or a part that was modeled maybe looser or more accurate than this deviation map, it's going to be really helpful for anybody interpreting that model. So you can take a screen capture, or a couple of screen captures. This acts as kind of a poor man's inspection tool with the multiple images that you can save out. Okay, now that we have the accuracy analyzer saved, we can export this model out. We might want to save it as an IGES file or a step file. So this can be a step, an IGES. You can save it as a parasolid as well. So let's just save it as an IGES exported solid. Okay, and that's easy enough to save out. The other way we can export is to natively save the geometry as a Creo format or an Inventor format, or what I have on my computer is a SolidWorks format. So what this command does is it will go through this history tree and send the commands over into SolidWorks. And you have to have SolidWorks or whatever CAD package you're using on the computer to run this live transfer command. You'll see what it does as it's running. Okay, so SolidWorks is launched, and then the DesignX software starts sending the features over one by one. The sketch and the extrusion with draft, the pocket that was cut out, the surface that was used as a cutting tool and then deleted, the revolve feature, the revolve sketch, the last revolve sketch. I think we dimensioned that up. There's a couple of dimensions that are showing up. We added a couple of cuts, some fillets, and I believe the slot feature was fully dimensioned, fully constrained. So that has all the constraints built in. The final cut and then the final shell of the model was added to finish the entire process. And what we can see is, let me just hide the planes. This is a final completed model that really accurately represents the shape. So what we do is we save this out as a native SolidWorks format, and you can save this out as a solid model, and then that would be the end of the process.